All right, hello, my wonderful students. This is part 2 of Foldable number 1. So for this one, once again, color is that black? Okay, cool. Once again, we have our equation 3x to the fourth plus 12x squared is equal to 6x cubed. And once again, first thing we're going to do is we're going to get the right side equal to 0 by subtracting minus 6x cubed to both sides. When we write this in descending order according to the powers, we have 3x to the fourth minus 6x cubed plus 12x squared, and then 6x cubed minus 6x cubed subtracts to 0. Once again, we're going to look for a common factor. For this one here, I noticed that my common factor is actually x squared. Well, it's actually 3x squared because each one is also divisible by 3. So we're going to go ahead and do that. 3x squared. What's left over is just 3 divided by 3. 1 x to the fourth divided by x squared. X squared. Negative 6 divided by 3 is negative 2. X cubed divided by x squared is just x. And then 12 divided by 3 is positive 4. X squared divided by x squared, 1 equals 0. Alright, so because we have equals 0 here, any coefficients we have out here, we can just divide by. For example, if we did this, divide by 3, these would reduce, and this would turn to 0. So we would still have x squared minus 2x plus 4 equals 0. I know what you're thinking, like, why wouldn't we just divide the x squared? Because we need to use that as a 0. So we already know that, how we did before, x squared is going to equal to 0. So when we take the square root of both, we're going to see that x is equal to 0, plus or minus 0, which is still 0. But I didn't want to factor that out because then we wouldn't have that to use. It wouldn't be there. So for this one, let's go ahead and do some blue. I know that this is not factorable. If I do it up here, there's no number that you can multiply to get 2, but add to equal 4. The biggest possibility would be, 1 and 2, but 1 and 2, 1 has to be negative. So our biggest number possibly can be 1. So this is not, that means it's going to have imaginary solutions, which is okay. We're just going to have to work them out using the quadratic formula. For these problems, you're not always going to get a real solution. Imaginary solutions are possible for these. And I think Foldable 3 and 4 will kind of show you what that looks like in the graphs. So let's go ahead and get this one started. So we have, if you guys remember, quadratic formula is x is equal to negative b, or negative 2, plus or minus the square root of b squared, which is negative 2 squared, minus 4 times a, which is 1, times c, which is 4. And all of this is over 2 times a, which is 1. All right, first things first, negative times negative 2 is positive 2, plus or minus the square root of b squared is 4, minus 4 times 1 times 4 is minus 16, all over 2. So this is going to give us a negative 12. Excuse me. And negative 12 can break down as 4 times 3. And this would be 2 root 3. But because we have a negative in there, it's also going to take out an I. So this is actually going to be 2 plus or minus 2i root 3 over 2 you can divide each of these by 2 and get 1 plus or minus I square root 3. And that ends up being our answer. So our 3 zeros are 0, comma. I guess 4 zeros, because this would be multiplicity 2 since there was 2 of them. So 0. Our next one is 1 plus I square root 3. And the last one would be 1 minus I square root 3.